All right, so last class I did number 1 with you guys, so I'm going to run through it again really quickly, and then we're going to work through a couple of these other problems. Okay, so again, number 1, we give you most of the vital information. We give you the parents. We give you this, which is, what is this trait? What is the trait we're talking about? Cocoons. What is the alleles? Yellow and white. You must be specific. Okay? So, here are our parents. Does it matter what side I put the parents on? No. As long as I don't split them, I can keep them on one side. So let's take first parent, big C, and the other parent is, and that when you write these, literally exaggerate how big and how small you're writing these. For example, this would be little c,
Wait, stop for a second. Go ahead.
little c. Okay? Literally make it that big of a difference, because when we get to the dihybrids, you're going to have a lot of letters in there, and you want to be able to see the difference quickly. All right? So we bring these together. We get a big C, little c. We bring these two together. Big C, little c. Big C, little c. Big C, little c. Okay? So, genotype and phenotype. Okay? As I said before, are you getting any points for this part? No. Because we're taking you way past 7th grade. We're going to give you points for interpreting it down here. Genotype and phenotype typic ratios. Okay, so the genotypic ratio. Anytime you hear genotype, think letters. Letters, letters, letters. How many big C, little c's do we have? 4. So when we write this, 4 big C, little c. We want to see that ratio. Okay? Phenotype. When you get the phenotype, it's what it looks like. Okay? What characteristics are we talking about? Do I need to look up here, or can I use my genotypes? I can use my genotypes. Good. Okay? So all 4 of these are going to look like what? Yellow cocoon. Good. So we are going to write it as 4 yellow cocoon. Okay, so we did that one together right before the end of last class. All right, now let's take a look over here. What's our trait that we're going to be talking about? Fur color, right? Or fur length. Okay, what's our alleles? Short fur, long fur. Good. Okay, they give us our parents. Okay, now this first parent, is this parent heterozygous or homozygous? Heterozygous, because hetero means different, right? The prefix. So I'll take that first parent, put it up here. What about this second parent? Homozygous. Recessive. Good. You got to have that second part. Okay. Up here. So again, we bring them together. Meet in the box are big F, little f. Big F, little f. Bring them together. Little f, little f. Little f, little f. Okay. So what is my genotypic ratio going to be? Good. 2 big F, little f, and 2 little f, little f. Good. Now, what's my phenotypic ratio going to be? I'm going to look right back here. So I'm going to have, what is this? These 2 big F, little f's going to look like? Too short fur. Good. And 2 long fur. Good. Very good. Okay? So, make sure you have these filled out and write these ratios correctly, because that's what we're really going to look at to see if you can understand the Punnett square. All right, on to the next 2. What's our trait we're talking about? Eye color, right? Eye color, yeah, you're hitting around it. Eye color. What are our alleles, Isabel? Red eye or black eye. Good. So, heterozygous or homozygous? Heterozygous. Good. So we're going to cross those. Take one parent on one side, one parent on the other side, and we're going to bring them together. Big E, big E. Bring them together. Big E, little e. Big E, little e. Little e, little e. All right. What is my genotypic ratio?
One big E, big E, big E.
One big E, big E. Good.
Two big E, little e, and then one little e, little e.
Excellent. Good. So we have a 1 to 2 to 1 ratio. Get used to recognizing patterns when you do these Punnett squares. Anytime we cross a heterozygous by heterozygous, you're going to get a 1 to 2 to 1 genotypic ratio. Okay. So once you start recognizing these patterns, it's going to move. You'll start to move a lot quicker. Phenotype. Do I? Good. Tell me how you got it.
Because the shit like the one big E was already black, and then the two big E's, the big E like dominates the little E, so it's black.
Good. So we're basically tallying these two because they're both black eyes. So we have 3 black eyes
And one red eye.
and 1 red eye. Good. So these verify each other. Okay. The genotype should verify your phenotype. It's kind of a quick check to see if you kind of got it together. Any question on these? These are straight monohybrid problems, very straightforward and to the point. But this is how we want you to write those genotypes and phenotypes. Okay?
Should you have written one homozygous red, or one homozygous black, and 2 heterozygous? Do you say that? Not for phenotypes. You see phenotypes. You don't. The genotypes reveal the phenotypes, but the phenotype's what's actually expressed. So let's go to these questions here, and we'll come back. So we should be able to answer all these except for the bottom 2.
Can you see a recessive and know its genotype? Can you see a recessive and know its genotype? Yes. Right? Because if it's recessive, it must be little l or little l. Right?
Like right here.
Yep.
Okay?
Can you see a dominant and know its genotype? No. A dominant could be written in 2 ways, correct? It could be big E, or it could be big E, little e. Do we know which one it is just by looking at it?
No.
No. Okay? Which is what we're going to get to later when we talk about a test cross. That's how we try to find out which one they are.
Test cross.
Test cross. Okay? Can a dominant crossed with a dominant produce a recessive? Are you sure?
Are you sure? Yes, when though?
Yes, they can when the parents are both heterozygous, right? Isn't this dominant? Isn't this dominant? And would they produce? They can produce a recessive child if they're heterozygous. If a dominant and a recessive are crossed and the offspring are all dominant, what does that tell you about the dominant? What does that tell you about that parent? A dominant and a recessive were crossed. What does that tell you about the dominant parent in terms of their letters, their genotype? Are they heterozygous or homozygous? Homozygous.
That was like this cross here. It's not filled out. Remember that one?
Very good. So here's a dominant crossed with the recessive, and we got all big C, little c's, right? So they showed all dominant.
Okay. This is kind of a follow-up.
If a dominant and a recessive are crossed, and the offspring are all dominant and recessive, so all the offspring are dominant and recessive, what does that tell you about the dominant parent? That parent was, say it louder, heterozygous. Very good.
Like this one.
Yep.
All right?
Yep.
You have a small pool of answers, but a whole bunch of questions. We're going to ask them several different angles, and we want you to be able to apply that. Right, do you want to go to the back here?
Yeah.
Right, so let's do this. Now, guys, we may try and pause a little, but your quiz, I don't know why people are talking, your quiz is going to be more reflective of this. We are not going to give you big B, little b. We're going to say, tell me the homozygous or the heterozygous. We will give you background like this. And one of the things Mr. Matheny constantly tells you guys, what do? Underline what's dominant. Underline what's recessive. So what do you want him to do with this? Maybe leave
All right. So number one, get used to the word problems coming. This is kind of how we're going to explain it. So number one thing I want you to get used to doing, no matter what kind of problem it is, underline, underline, underline. Okay. Separate the important information from a lot of the kind of filler words. And the guinea pig. So on everybody's sheet, I want this underlined. Black coat color is dominant. Big B. Brown coat is recessive. Okay? So you can go back to that anytime. It's underlined and it's quick to get to. Right.
Strongly recommend you do that when you get to the quiz. Next class period.
So this first example here. Big B, little b is, it's another word for that. Heterozygous. Homozygous. Recessive. Must have that second part when you use homozygous. Say it out loud. Good.
Cross C.
Homozygous, recessive, homozygous, dominant.
Good. Because when you get your quizzes, you're going to be reading along, and that's what we're going to give you. So you should be able to put the letters out there real easily.
We'll tell you what letters dominant, what's recessive in the reading, but from that point on, we expect you to use the word vocabulary. So this isn't just know the vocabulary, it's know how to use it. There's generic matching where you say, oh, homozygous means this, but then you have to demonstrate you know homozygous means something by doing it and setting up the problem.
All right, so let's put our parents in our Punnett square. We have heterozygous, big B, little b. We have a homozygous recessive,
That's acting weird.
little b, little b. So cross them. All right, what's my genotypic ratio? So, big B, little b. How many of them do we have here?
2.
Little b, little b.
Make sure your finger's not hitting the buttons.
What's my phenotypic ratio? Good. 2 black, because it has the dominant, and 2 brown. So that's what you're writing in here. 2 black, 2 brown. Any questions there? Very good. 2 black, 2 brown. All right, let's plug this one in. Big B, little b. Big B, big B.
phenotypically, both of them are what? Black fur. Right?
So our genotype, what's our genotypic ratio? Good. Phenotype.
Two black, male, two black.
4 black, right? Because isn't this show black as well? It's heterozygous, but it shows
You don't know
black.
that.
4 black. Okay. All right, last one.
Elaborate on them. Same genotype, different phenotype. Or
Yes.
same phenotype, different genotype.
So again, we talk about
Hey,
homozygous dominant shows black. Heterozygous shows black. So again, can we look at a dominant phenotype and know its genotype? Can we?
Yes.
Can I look at a black fur guinea pig and know which one of these that guinea pig would be? No. I don't. All I know is they show black, and it's the dominant gene. Okay? Which again, we're going to come back to. How do we figure this out? How do we find out whether they're homozygous dominant or heterozygous? And that's going to come back to our test cross. Okay? All right, last one. Little b, little b. Big B, big B. Again,
Yes.
as you do these, you're going to start to recognize patterns. Okay, filling these out. Big B, little b, big B, little b, big B, little b, big B, little b. Genotypic ratio is?
4 big B, little b.
Excellent. Phenotypic ratio is?
4 black.
Excellent.
yeah, you don't. All right, this has been asked a couple times. You, at this point, we do not know if the offspring are male or female. We did give you the gender to help set up the cross, but later on, we will expect you to know what's called sex-linked traits. For now, you shouldn't be saying gender at all, just the phenotype.
Don't let this confuse you.
Hey guys, look at those two crosses. They both produce the same phenotype, but they both had different genotypes. Both was homozygous dominant times the heterozygous, homozygous dominant times the homozygous recessive. Or look at the cross A. A dominant times a recessive produces dominant and recessive. Means you got a heterozygous parent. Cross C, a dominant times a recessive produces all dominant. Means you got a homozygous dominant. Start recognizing these patterns. Are there any questions?
Very good. Very good.
Mr. Matheny, you want to say brought to you by?
Brought to you by
Yours, Moran and Matheny.
Moran and Matheny.